ended somewhere here, right, where we say that we're gonna be doing the systems of linear equations. So let me see, and I think before the system of linear equations, we said that we're gonna be doing some adjoint method and also do some Gauss elimination. But we did one example, which was this one for Gauss elimination. So today we're gonna be doing this one of a where the matrix is. Let me see. Yeah, this one. So we'll try to find the inverse of this matrix. So today we're gonna be looking at how can I find the inverse and so on, right? So let me see how to find the inverse of B. So I'm just gonna copy the matrix. We have 2, 7, 1, 1, 4, minus 1, 1, 3, 0. So I'm just gonna copy it like this. Yeah, but I think that let me just do this so that I don't have to write a lot of things. So here we'll be looking at, I think that matrix was saying, so let me say we'll be looking at inverses, right? So I said that the methods that we're gonna be looking at, the Gauss-Jordan elimination, and also we're gonna be looking at the second one is the adjoint method. You see, right? So when we talk about the Gauss-Jordan elimination, this is the method where we talk about we're having a matrix A, then we take an identity matrix saying that if now I apply some operations, or maybe I take A to the other side, it's going to become A inverse, but when I take I to the other side, it's going to remain as it is, meaning that the inverse of an identity matrix will remain the same. So the inverse of an identity matrix, it is itself. The inverse of an identity matrix would be itself. So we see that. So in other words, we are saying that the inverse of an additive 0 will be an additive inverse. Your additive identity will be itself. You see right there, meaning that the inverse of 0, you know that it should be itself. Inverse is something that when I add it to the original matrix, it should give us that matrix. So, or should give us 0, actually, not that matrix should give us a 0. So the inverse of 0 would be 0. The inverse of 1 would be minus 1. I'm sure here we understand what you're saying, right? But the inverse of an identity matrix, an identity acts like a 0 in this case. So it will be itself. It won't change. You see right now? So that's what we have. So on the adjoint method, we're going to be talking about if I want to find the inverse, I'm going to have to first find the determinant of A, then I multiply by the adjoint of A. And what do we mean when we talk about an adjoint? Adjoint, we're talking about a cofactor matrix. But then that cofactor matrix, we put or we transpose it, right? We must find the cofactor matrix and then we transpose it. That will be the adjoint matrix. So we're gonna be using these the most. So when we come here, we look at Gauss-Jordan. We say that we have an example here where they said we have B, which is equal to, it was 271 and 271. Let me see that matrix. 27114 minus 1. 14 minus 1. So we have this matrix. Now we must find the determinant we must find the inverse using Gauss-Jordan elimination. So first, let me say by Gauss-Jordan elimination. So by Gauss-Jordan elimination, what I'm gonna do first, I'm gonna take the B. I'm gonna say this is B I. Then I'm going to say I'm gonna substitute my B, which is 2 7 1 1 3 0 1 4 minus 1. You see, right? Let me just do this. 7 4 1 minus 1 0. So this is why am I closing there? Then this is the matrix, right, of B. Then I put the identity matrix. Remember, the identity matrix will depend on the number of columns of the matrix which I'm applying it to. So like here we have B. We know that in this case it is a 3 by 3 matrix. So it will depend on the number of columns, which is this one. This is M by N for the column. So we know that this will be I3. So even if someone had written I3 there, it will be correct, right? So, but as we're just gonna keep it as a reason the guide, we say BI. Then I'm gonna put that 3 tells me that I have 3 diagonal ones. 1 1 1. Then the rest is 0. That's an identity matrix. You see, right? So now the idea is to have a leading one. Remember, we're gonna be using for this, we're gonna be using row echelon form. We're gonna be using row echelon forms for us to compute this. So now for a row echelon forms is that we must have a leading one here. After having that leading one, we're gonna change this to a 0. You see, right? So now we should work on the leading one. It means that we're going to interchange rows. We see that now we're interested in a leading one and we have 2 leading ones. So we're gonna take the one which is the closest. Always the case. We're gonna take the closest one. We're gonna put that row here. This row here, anything about row, that row I'm gonna put it there. Then I take the second row, put it here. So I'm just gonna interchange them, then paste the last one. Then here what I did is row 1 interchanging row 2. We see, right? And then now I have that leading one. I'm just gonna highlight it. Let me just highlight it. 1 4 minus 1 0 1 0. You see, right now, just gonna highlight that leading one. So now after highlighting that leading one, I'm going to just change the rest to a 0. You see, right now, I'm just gonna change the rest to a 0, which are these. Gonna change this one, it's 2 1 to a 0. So using row echelon form, I said that we're always gonna check which row we're talking about. It's row 2. I'm gonna subtract row 1 because it's the one which I've copied there and paste there. You see, right now. Then this is row 3 minus row 1. This is the default formula. We're just gonna first use the default formula, then we think which constant can I put where and where, right? So for those constants, I'm gonna look at, I say the constant of row 2 is 2. You see, right? I'm gonna put it here. The constant of row 1 is 1. Put it here. So I'm gonna take the constant of row 2, give it to row 1, constant of row 1, give it to row 2. So it means that at the end I'm going to have 2 here. You see, right? Here I was going to have 1, but I don't need that 1. Then I check the last row. The constant of row 1, it's of row 3 is 1. The constant of row 1 is 1. So the 2 constants are 1. Even if I can take this constant, put it here, take this constant, put it here, it won't make a change. So I can just keep the formula like that. To be fine like that. You see, right? So this is the first formula we have for changing that 2 to 0. So we know initially that this is going to be a 0 and this will be a 0. So now let's check. 7. If now I apply this formula, I have a 7 there. I'm gonna say 7 2 times that 4 there on row 1, right? Since that on row 1, I'm gonna substitute 4. So this is 7 minus 8 is minus 1. So we have minus 1. And then here, this is 1 minus 2 minus 1. 1 minus 2 minus 1. You see, right inside there. Then this will give us 1 plus 2, which is 3. And then we are going to have 3 there. Then this is just 1 minus 0 to give us 1. 0 minus 2 minus 2. This is 0. So if I substitute this in the formula, these ones are easy to check what is it that I'm going to get if I use this formula. Then I come to this one now. This is simple, I just subtract. 3, make sure that you subtract the correct ones, right? Sometimes you make a mistake of taking this one, you subtract this, while you're supposed to subtract row 1 instead of row 2, right? So you subtract anything in row 1. So 3 minus 4, it's minus 1. 0 minus minus 1, it's a positive 1. 0 minus 0, it's 0. 1 minus 1, 0 minus 1, it's minus 1. 1 minus 0, it's 1. Then this will be the format. So now we check. We had the leading 1 here. You see right now. After having that leading 1, what must happen? I must change this to a 0, and this is complete. It's true. So after having that, I'm going to move diagonally to the right to check if I have another one, leading 1, if I can have another leading 1 somewhere here. You see right now. So since I found that leading 1, but the problem is it has a negative. Now it means that I must get rid of that negative. I must change that to a positive 1. So I must multiply that row by a negative. So it means that I'm going to do this. I'm just going to come and say this is equals to 1, 4 minus, I'll copy the rest. Then I multiply this row by negative. So row 2 by negative. And this one remains the same. Now we have that leading 1, right? So since now we have the leading 1, what we are going to do now, we are going to copy the one which we want to use and paste it there, right? And also the one on top, because row number 1 I don't want to change it, so I'm just gonna copy that. Then now I copy this one, just gonna copy it with a different color so that you can see. Then now I want to change. Remember, after having a leading 1, everything below leading 1 should be a 0. After having a leading 1, everything below a leading 1 should be a 0. It means that negative 1 we need to get rid of it. And here's another thing, right? Today in class we spoke, those are doing SNT02, we spoke about an upper triangular matrix and also a lower triangular matrix. So now let's just take some space here and let me explain, right? When we talk about, remember, this is a matrix, A, B, C, D, E, F, G, H, I. This is a matrix, and this is a 3 by 3 matrix, and this is a full matrix. You see right now. So now the moment now I take this matrix, let me say this 3 by 3 matrix. The moment I take this matrix, right, I say remember, this is a diagonal, these are our diagonal points, right, or entries. The moment these entries are something else other than 0, and these ones are 0, this 3, this one we call it an upper triangular matrix. And then the moment these ones are non-zero, the moment these are non-zero, the moment these are non-zero, and these ones are zeros, this is a 0, 0, 0, this is called a lower triangular matrix. You see right now, the moment that becomes as I'm explaining. So now when we talk about a matrix of row echelon form, we are saying that we need a 1, 1, 1. We don't care about this. This can be anything, right? So far we don't care about this. It can be anything. It can be anything, but these ones should be a 0. In other words, we know that this is a what? This is a, I can say, row echelon form. And this is a upper triangular matrix. This is an upper triangular matrix, right? And it's in row echelon form. So we have a leading 1, a 0 below, leading 1 a 0 below. We don't care about what's on top. So whenever you are changing something to a row echelon form, don't change this to a 0 first before changing all this to a 0. You see this one here, this should always be your last entry, this one to change. First, you change these two. So you're gonna do the first job, change those two. You do the second job, change this one to a 0. You do the third job, change this to a 0. Then you do the last job, you change this to a 0. Making sure that everything that you do, remember I cannot change this to a 0 if this is not a leading 1. I first need to make a leading 1, right? I cannot change this to a 0 if this is not a leading 1. And I cannot change this to a 0 if this is not a leading 1. That's why it's very important to do them in that case. You see it? So the moment now I come to check the upper top. Now let me say now I come and say my matrix is like this. There's this kind of matrix now. Let's say the matrix is like this. I have A, B, C. I have 0, 0, 0. This is a lower triangular matrix, but it's not a row echelon form or reduced row echelon form. You see right now, it's a lower triangular matrix. This is just a lower triangular matrix. But the moment, wherever we have a leading 1, whenever we have a leading 1, we find that the values below and above that leading 1 are 0 or elsewhere. We know that this will be it's in both lower and upper triangular matrix. So this is a full matrix, right? This is a full matrix. And that full matrix is called an identity matrix. So I can just call it an identity matrix. It's called an identity matrix. And this is in reduced row echelon form. This is in reduced row echelon form. You see right now. So this is the case for this. I can just do this because I want to erase them, right? I can just screenshot them and then I'll send them to you guys. So now another thing, right? When we are looking at let's check our formulas. Whenever I'm changing the numbers below to a 0, this one should always be the case. I'm always going to take the bigger row, subtracting the smaller row. You see right now, bigger row, subtracting. You'll never see me saying row 1 minus row 3 whenever I'm changing this this ones here. You see right? I'll only do this if I'm changing this to a 0. You see right? Keep that in mind. These rules are very important. You'll find yourself going the wrong direction if you skip them or if you try to, I don't know. So now what we can do here, let's do this using REF. And then what we can do here, we can do this. We can say that, yeah, let's go back to what we're doing here. I wanted to, since we have a leading 1 here and we have a leading 1 here, let me just highlight them. All right. Then we see what we can do with them. We had the leading 1 here. We had the leading 1. We know that anything below that leading 1 should be a 0. This one is not yet the leading 1, right? We're not yet there. It will only become a leading 1 if these are zeros. You see right now. So it's not yet a leading 1. So we want to change this one to a 0. So for me to change that to a 0, I'm going to focus on this 2. You see right now. It means that I must take, first before I focus on that, remember this is row 3. I'm subtracting row 2. So you must subtract the previous one with a leading 1. I can't subtract row 1. Even though that one has a leading 1, but I must subtract the previous one with a leading 1. Reason being, so that these zeros do not get affected. If I subtract this one, I'm going to have 0 minus 1. This one 0 will be affected, you see. So it should not be affected. And if you check here, 0 minus 0 will still give us a 0. That's why we're using row 2. So I'm subtracting row 2. And then I ask myself, what is the constant of row 3? It's minus 1. Constant of row 2, it's 1. I'm going to take this constant, give it to row 2. Take this constant, give it to row 3. So it means that this is going to become plus 1 if I take that constant. So this will just be row 3 plus row 2. You see, right? So 0 plus 0 will give us a 0. Minus 1 plus 1, it's a 0. 0. 1 minus 1 minus 3, it's minus 2, 0 minus 1, it's minus 1, and then minus 1 plus 2, it's 1, 1 plus 0, it's 1. Then this will be the case, right? Then we realize that now let's check let's highlight leading ones. We have a leading 1 and zeros below, a leading 1 and zeros below. What do we need next? We need a leading 1 when we move diagonal. You see right now? So it means that now we must multiply this row by negative 1 over 2. Remember, those who are in those who are in SMTA, remember that there's nowhere in vector spaces where you are talking about the property of dividing. You see, right? Or those who are in determinants, we know that, or SMTH, we know that there's nothing in the determinant form that we are talking about dividing, right? Or constants that are divided. So what we should do is constants can never divide here. They will always multiply. So even if I say negative 2, I can never divide by negative 2 for me to change this to a 1. I must multiply by negative 1 over 2. You see that? So I'm going to copy this one first. I'm going to copy these ones so that I can have my leading 1 there. So I'll change that. Minus 1, 2, 0. Then this one, if I multiply this row by negative 1 over 2, this is going to be 0, this is going to be 1, this is going to be 1 over 2, minus 1 over 2, minus 1 over 2. You see, right? Then now, I see that now I have all the leading ones that I need. But now I need to change this to a 0 and this to a 0. You said I need to change this to a 0. The question is, how do I do that? So, for me to do that, I'm going to come and say, I need to start here, right? It means that I need to copy this only because these ones are going to be affected. So I won't paste them. So I'm going to say this is 0, 0, 1, 1 over 2, minus 1 over 2, minus 1 over 2. Right? Then this is row what? This is row 2, minus, I'm subtracting row 3, obviously. Row 1, minus row 3. So you see, when I'm doing now this, when I'm doing now the upper part, right? When I'm now, remember this is our row echelon form, this one. This is the row echelon form. This is the complete row echelon because everything below is 0. And this one is called an upper triangular matrix. You see right now. So now since we see that now we're in row echelon form, we can now want to change this to a reduced row echelon form. Reduced row echelon form says that every column with a leading 1 has zeros elsewhere. You see, elsewhere we're talking about each column with a leading 1 has zeros above and below it. You see, right? So it means that these two must be, or these three values must be zeros. That's what we're going to look at. So now let's see. We want to change this to a 0. So the constant of, I'm going to check the constants first. The constant of row 1 here is 1. The constant of row, of row 3 is 1. Constant of row 1, it's minus 1. So I'm going to take this constant, give it to row 3. Take this, give it to row 1. So it means that this one is going to become plus. Then the constant of row 2 is minus 3. This is minus 3. And this one is 1. So it means that I'm going to take this minus 3, give it to row 3. Take this, give it to row 2. So it means that this will become plus 3. You see right now. So now this will be, let's see, row 2, let's start with this one. Row 2 plus 3. So 0 plus 0, just have to get 1 plus 0. It's 1 minus 3 plus 3, it's 0. Then this one's minus 1 plus 3 over 2. It's minus 2 plus 3 over 2. It's 1 over 2. And then the other one is 2 plus, not plus, it's going to become minus because of the negative there. Minus 3 over 2, 4 minus 3 over 2, it will be 1 over 2. 1 over 2. So, Muna, I have a class now, I'll text you. This will be 0 plus. Oh, it's going to be minus also. Minus 3 over 2. So this will just be minus 3 over 2. So now let's look at the first one. Row number 1. Row number 1 is just 1 plus 0. It's 1. 4 plus 0. It's 4. Minus 1 plus 1 is 0. 0 plus 1 over 2 is 1 over 2. 1 minus 1 over 2 is 1 over 2. 0 minus 1 over 2 is minus 1 over 2. We see, right? Then now, let's highlight those leading ones. It means that the only thing that we need to change is this one to a 0. You see, right? So we can just copy these and paste here. We're only going to copy the other ones. This 1 over 2, 1 over 2, minus 3 over 2, 1 over 2, so 1 over 2, minus 1 over 2. And then, now, we need to change this 4 to a 0, right? So here what we're going to say that we're in row 1. And the only row we can use to change that 4 to a 0 is row 2. The one with the closest leading one, right, for that column. So we can say row 1 minus row 2 first. And the constant of row 1 is 4. The constant of row 2 is 1. So I'm going to take this constant, give it to this. This constant, give it to this. So it means that this will end up being minus 4. You see, right? So 1 minus 0 is 1. 4 minus 4 is 0. 0 minus 0, 0. Then I need these ones. 1 over 2 minus 4 over 2, which is like minus 3 over 2. And then, and these two are the same, it's something like similar. And then minus 1 over 2, minus 4, and 2, 3 over 2. So this is just something like so put this minus inside. So this will become positive, minus 1 over 2 plus 12 over 2. Then this is 11 over 2. Yeah, something like this. (11/2). So this would be the case, right? So it means that when we check here, this is the matrix, the inverse matrix. If we check, then this will be the inverse matrix. This would be the inverse matrix. You see, right? Then would have been done now to finding the inverse matrix using Gauss-Jordan elimination. Any question? Any question? Anyone with a question? If you have any question, you can ask. Let me check these ones, the comment sections. Maybe some of you want to type, right? The one was asking about swapping constants. I think I've done that multiple times. Were you able to get it? Because I think I've been doing that multiple times, and every time we use Gauss-Jordan elimination, we're gonna be doing that a lot. Were you able to do that, to see it, actually, to understand? All right. Your message appeared there. You saw one of it.
No, I was asleep.
It was the group.
From the group. It doesn't matter.
Let me do this. I was attending that one was knocking here. So now I think what we can do, right? Let me see. Since we've done this, let me see what else we can look at based on this. So since we know how to do how to approach this kind of a problem, if they say you find the inverse, you know how to find the inverse, right? I'm sure you'll know how to find the inverse. So the inverse is just like that, using Gauss-Jordan elimination. It means that the next thing that we need to do now is to find the inverse using the adjoint method. So with the adjoint method, right, check here, the inverse, we found it to be like this. And we realize there's something common there. What is the thing which is common? 2. If I factor out that 1 over 2, this will be our cofactor matrix. So it's also simple to find the cofactor matrix using Gauss-Jordan. You can still find it. You start by you used to find the inverse, but this is risky, right? So you might not get to the solution easily. So unless if these ones are the same. If these ones are the same, then you can easily do that. But also there's another way of finding a cofactor matrix. There are 2 ways of finding a cofactor matrix. You can use the cofactors. You find the cofactor of every entry, or you just go and do this route, then you just factor out some constant there so that the remaining can become a cofactor matrix. So now we're going to find this, the cofactor matrix of that matrix. So which means that we are going to use the adjoint method, right? So let's go and see. So now just gonna copy this. Now we are not gonna use the Gauss-Jordan elimination. Now we're gonna use the adjoint method. Now we're just gonna use the adjoint method. Come and say using adjoint method. So using the adjoint method, the formula is like this. If I want to find the inverse of B, it means that I need the determinant of B. Obviously, I already know the determinant of B here will be 2. You see right now. So you can still check it anyhow. So also I need the adjoint of B. How do I find the adjoint of B? Let's start with the adjoint and then we can come to the determinant. We can find the determinant in many ways, but what's interesting now is the adjoint of B. So for me to find the adjoint of B, I said that first I need to find the cofactor matrix. So I'm going to name it C. The C needs to be somewhere here. So for me to find this, I'm just going to have this. Let me show you something here. This is always going to be positive, minus, positive, minus, positive, minus, positive, minus, positive. So I'm just going to use that rule for a cofactor, right? Now let me use the formula, write the formula for a cofactor. How to find the cofactor? How to find the cofactor? Cofactor, I need minus 1 I plus j times the minor. You see that? So that's what I'm gonna do. I'm gonna be doing here. I'm just gonna say minus 1 I plus j. In short, that one is 1 plus 1. The first A matrix is 1 plus 1. It's 1 1. 1 plus 1. Then times the minor. This will be the minor, right? Then I come and say for the middle one, minus 1 1 plus 2. This is 1 2 matrix times the minor, minus 1 1 plus 3 times the minor, I come to the middle one, second row now. It's 2 1, 2 plus 1. This is matrix, it's entry 2 1, right? It's 2. I'm just gonna say 2 plus 1 minus 1, 2 plus 2 minus 1, 2 plus 3 minus 1, 3 plus 1 minus 1, 3 plus 2 minus 1, 3 plus 3. You see, right? Then this will be the case. Now let's go and check what are those values that are going to be there. Now this is the first thing that you'll be doing. Then you go and look for the values. Now for the first one, we want to look for this one. Which ones are we going to write there, right? We're going to look for this one. Now let's see. This is the one. This is A11, right? So I can just write them here. We know that this will be A11. 1, 2. No, it's not A11, it's B11. Since this is a matrix B. B11, B12, B13, and B21, B22, B23, B33, B32, B31. So now if we check this, when I'm here at B11, right, I horizontally circle everything that is aligned with that, or highlight, and vertically highlight. Whatever that is left out, this is what is left out, 4 minus 1, 3, 0. So I'm going to write it there. This is just 4 minus 1, 3, 0. That is everything that is left out there. You see right now. So I'm just going to write it there. So it's just going to be 4 minus 1, 3, 0. Then I come to this one. Vertically, vertically and horizontally. Then I have 1, 1 minus 1, 0. So it's 1, 1 minus 1, 0. 1, 1. Thinking something like this. Let me check. Oh, minus 1 is on top. Minus 1, 0. You see, right? Then I come to the third one, the last one there. This one at the corner. This one. It's gonna be circled with this one and this one. You see right now? So when I circle these, I'm gonna be left with 1, 4, 1, 3. So 1, 4, 1, 3. Just like that. So now I come to this one. It's just gonna put it like that, like this. Then I'm gonna be left with 7, 1, 3, 0. 7, 1, 3, 0. Gonna come to the middle one. This one is just gonna go like this. This 2, 1, 1, 0. Come to the one here at the end. This one just circle vertically, horizontally. We have 2, 7, 1, 3. 2, 7, 1, 3. Then we come to the last row. Seven, 1, 4 minus 1. You come to the one here. Two, 1, 1 minus 1. Then come to the last one. 2714. So now we see, right, that it's what, let me see, it was 2714. Yeah. So now we see, right, that this is what we had for this cofactor matrix. So now we can just simplify it. We know that C will be equals to, this will give us positive minus 1 squared is positive 4 times 0. So this will just be like this, 4 times 0 minus, finding the determinant of each of these, right, minus 3 times minus 1. And then the determinant of this one here, this will be negative, minus 1 to the 3 is negative. This will just be 7 times 0 minus 3 times 1. Find the determinant of the last one, 3 when minus 1 to the 4 is positive, so it's just gonna remain as positive. 7 times minus 1 minus 4 times 1. We come to this one here, it's 5 there, means negative. 2 times minus 1 minus 1 times 1. So we'll find the determinant of each. And then this one here, it's 6, which is exponent is positive, so this will just be positive. We're just gonna compute the determinant only. And then we come to this one in the middle here, it's positive, so it's gonna remain like this, 2 times 0 minus 1 times 1. This one is negative, exponent is odd, 2 times 3 minus 1 times 7. And then we come to this one here on top, exponent is odd, so it's gonna be negative 1 times 0 minus this will be 1 times minus 1. Then we check the last one, right? The exponent is even, so this will be 1 times 3 minus 1 times 4. You see, right? Then now we check what are these values. These are just our cofactor. This is just our cofactor matrix, right? Then this one here will be positive 3. This one will also be positive 3. Then minus 7 minus 4 should be minus 11, right? Let's see, minus 7 minus 4, it's minus 11. And then this one here is positive 1 minus 1. This one here is minus 1. This inside is minus 2 minus 1 minus 3. This is positive 3. 8 minus 7 is 1. 6 minus 7 is minus 1, positive 1. Then 3 minus 4 is minus 1. Then this is C, right? And then we transpose it. When I transpose, this will just be the adjoint of B. When I transpose, I take this row, make it a column. Alright, it means that this will be 3 minus 1 minus 1. Take this row, make it the second column. 3 minus 1 1. Take this row, make it the third column. Minus 11 3 1. We say, right? Then this will be the adjoint. If we check there, right, I think we can try to check here. Where is it? Somewhere here. We can try to check here. Let's see when we check what was the adjoint. Let's see. And there we got, let's see what we got. We got -3. Let me see, we got, let me see if we got it like that. That one is -3, right? This one is, yeah, I think maybe the negatives are, yeah, I think the negatives are a problem. I'll see where we made a problem of a negative. So these ones are supposed to be, this ones here, we got negative, negative, we got positive, positive, we got negative, positive, yeah, we got negative here. I'll check where did we make a mistake of the sign. Positive, we got positive, positive here, right? So it means that we're supposed to get something like this, right? So let me check if we made the sign somewhere. Unless if this side, let me see. Oh, I think there's no problem. I think what we got is correct. That's what they also got, right? Yeah, it's fine. I think it's fine. Yeah. We'll just see our determinant, what our determinant will be, right? Let's just see what, yeah, our determinant will be negative. Yeah, so now it's reasonable. So our determinant will be negative. So this is correct. We didn't make a mistake anyway. So it's correct. So now we're going to check the determinant, right? So the determinant of B is going to be, the matrix was 2, 7, 1. Remember the last one was 1, 3, 0. And then let me go check 1, 4, minus 1. 1, 4, minus 1, right? So we can use many things to choose to do the determinant here. So that we can use properties or we can use other means, but here the properties will be simple. I'm just gonna pick this column, is that right? And then change this to a 0. After changing this to a 0, then I reduce this matrix, then I find the determinant of this, I reduce it. So let's do that. So it means that for me to use properties, I'm just going to come and say I have a leading one here, so I don't even need a leading one. Remember, now I'll be using Gaussian elimination. It's called Gaussian elimination. Using Gaussian elimination. Remember, we have Gaussian elimination and we have Gauss-Jordan elimination. So with Gaussian elimination, I'm just gonna add row. This is row 2, right? Plus row 1. So here's how the formula for Gaussian elimination works. Remember, here I'm supposed to say row 1 minus row 2 minus row 1, right? This is the default formula. Remember, I'm changing this one up here. So these ones, whenever you're changing this 3, you should always take the small one, subtract it from the bigger one. You see, right? Or something that can happen, that you're subtracting the smaller one. Sometimes it happens, in most cases, right? I wanted to say this. When we are changing this 3, we subtract. When we're changing this to 0, we subtract. We take the small, let's say the smaller one, we subtract the bigger one most of the times. But here, this is the only operation we can make. You see, right? So it doesn't matter in this case. So we're just gonna put a default operation. We say this, right? Then what we're going to say here is, what is the constant of row 2 minus 1? Constant of row 1 is 1. So here, instead of, you say in Gaussian elimination, remember with Gauss-Jordan elimination, we interchange them. That is also using the row echelon forms, right? But this is Gaussian. With Gaussian, it doesn't say we interchange. Gaussian says that I'm gonna put a division in between these two. What is minus 1 divided by 1? It's minus 1. Take that minus 1, give it to this only. You see, right, ne? So this minus 1, this is gonna become positive. That is the Gaussian. You see, right? It says I'm gonna put the division there. So when they say use properties, this is what you're gonna be using. So this will be 1 plus 2 is 3. This will be 11. This will be 0. Then I keep this one. Then now, if we check here, now we can reduce. I have this one, I can reduce to this. I take this only. You see, right now? Now I can reduce this. I don't know how I took a screenshot there. So I can reduce, I'll have 1 times 3, 11. So remember, when I close this, I'm going to be left with 3, 11, 1, 3. So this will just be the determinant 3 by 3 minus 1 by 11. And this will just be 9 minus 11. This is minus 2. Then the determinant is minus 2. So it means that now I can come and find the inverse. So I'm just going to come and paste it here. That is like the determinant times the adjoint, right? And this will be the inverse, minus 3 over 2, minus 3 over 2, 11 over 2, 1 over 2, 1 over 2, minus 1 over 2, 1 over 2, minus 3 over 2, minus 1 over 2. If we check, these are the same, right, as the other inverse we got here. These are the same. These two being, this 3 being, not this 3, these ones being positive, these ones being positive. If we come here, the same being positive. You see right now? And the rest remains the same. Just like that. And 11 here. You see right? So those being positive. So we see that the inverse is the same. So that's how we do the adjoint and the Gauss-Jordan elimination. So on the adjoint method here, on the determinant, you see that I decided to use the Gaussian elimination, which is what we discussed last time we're doing determinants. I think even last week we discussed this type of a method. So to how do we apply Gaussian elimination? So I can do more based on this, because this is the simplest way to find the determinant. Because if I wanted to use Sarah's scheme, I would have to copy this, paste here, then do a lot of calculations down there. Or if I wanted to use Laplace expansion, I would do a lot of reduction, which takes time, right? So the Gaussian, I just applied one operation, reduce, find determinant. The simplest, even when you're given a 4x4 matrix, is the simplest. So I think now since we have done this, we can look at it and say, let me see what else that we can focus on. But this will be the last one, right? I think this will be the last one. But now since we have done this, it means that what I can do, right, I can give you this, guys, and say that go find the inverse of these matrices. Go find the inverses, or just say go find the inverses. I'll send this in the group. You'll go find the inverses, and then I'll see them tomorrow in class. I'll check them tomorrow in class. So you must find the inverses. I'll just check them. Tomorrow we'll be meeting at J0010. So I'll check them. It means that when we meet tomorrow, we're gonna be doing the systems of linear equation, where we'll talk about the no solution, unique solution, infinite many solutions, right? We'll talk about the system that is consistent and the system that is inconsistent, and then we'll see what we get. Matrix method. So yeah, this will be the last part, guys, and then I think we can stop here. Then tomorrow we'll finish this part, do also Kramer's rule, so that when we meet again the upcoming week, we just do the 3x3 systems with parameters, where we have to focus more on these unknown constants. All right, then that will be the last part of matrices. Yeah, so let me